Welcome to the Migration Assistant Enablement session on Reindex from Snapshot. Reindex from Snapshot, or RFS, is our solution for backfilling existing data from a source to a target cluster. In the last session, Tanner explained how to deploy the Migration Assistant solution, and in a future session, we'll explain more about our capture and replay option that can be used in conjunction or separately from RFS. This documentation page contains details of how to configure RFS, and I recommend reviewing it as you prepare for your migration, but the focus of this session will not be on configuration or deployment. At this point, your infrastructure has been deployed, and we can verify that you have active connections to both of your clusters. I'm logged into the migration console using the same process you saw previously. We're going to start the backfill process by taking a snapshot of the source cluster. First, I'm going to run a cat indices call to show you what's on each cluster. You can see that the target cluster is empty except for a few default or automatically created indices. And the source cluster has some of the OpenSearch benchmarks data on it. In total, it's about 20 to 30 gigabytes of data. Here's some of the larger indices on it. To take the snapshot, I'm going to start with console snapshot start. And this will send the commands to the source cluster to register and begin taking a snapshot. So we can check, that looks like it started successfully, and we can check the status with this. So it's in progress. We have a flag that we use on a lot of our status commands for various components of the system called deep check that performs a little bit more legwork to figure out what the state of a component is. So in this case, you can see that we're currently 23% done. And this is of the 43 shards, we have 3 successful shards fully completed, and the rest are ongoing. My source cluster here is a 6.8 cluster, and we have some data that is returned on 6.8 differently than it is on later versions of OpenSearch. We're not planning to address this issue for the time being, but it works fully in later versions of Elasticsearch and OpenSearch. All right, so I'm going to let this run for a couple more minutes. Now, when I run console snapshot status, you can see that it has successfully completed. We can take a quick look at this in S3 to verify. This is a bucket that's created by the Migration Assistant deployment infrastructure. So this is the stage name that we specified earlier and the region we're in. And this is the snapshot repo that was registered with the source cluster. This is the snapshot itself. This isn't very interesting or helpful as human readable data, but you will be basing our metadata and backfill migrations off of the underlying data here. With the snapshot complete, the next step is to run console metadata wait, which gives us a preview of what will happen when we migrate the metadata. First, you'll see the data that we're working off of. The source is a snapshot of our Elasticsearch 6.8 cluster, and the target cluster is a live OpenSearch 2.19 cluster. And then we have our migration candidates, the things that would be migrated as metadata here. There's an index template from Kibana. There are no component templates, and then there are the actual indices itself. These are all the ones that we previously saw on our target cluster. And then these system indices are being skipped because our default filter is to skip any system indices. And same with aliases. We only have the one, and it's being skipped. One option that this supports is to specify an allow list of index or index templates to be migrated. Perhaps a customer wants to manually set up a new mapping or a new sharding strategy for some of their indices, and they just want to create those on their own outside of our tool. In that case, they can include only the indices they want to be migrated by the tool. So we can do console metadata evaluate, and then index allow list. In this case, let's say geo names and so nested, but none of the logs indices. And we don't support exclusion lists, deny lists, but we're going to try for index templates. instead of, say we don't want this Kibana index included. So instead of doing a deny list here, we can just provide a item in the list that doesn't actually exist, and that will have the effect of excluding everything that is there. So we'll run that evaluate command again, see the output. Okay, so we've got the same clusters, and then the migration candidates, in this case, the Kibana index template was skipped due to the filter. The indices that will be migrated are geonames and so nested, and the rest of these are all skipped due to the filter we set. And then results 0 issues detected. So that was the same in both of these cases. But that basically means that to the best of our ability, we believe that the metadata we're looking at will be compatible with the target cluster. At this point, nothing has actually been written. So we'll see if we do another cat indices. There's still nothing in the target cluster. And that's expected because metadata evaluate is just a preview of what would happen if we migrated our metadata. If we're satisfied with what we're seeing here, we can change this to evaluate, or to migrate, sorry, to console metadata migrate. So in this case, I'm going to leave the index template allow list, but I'm going to take off the index allow list and change evaluate to migrate. We'll run that. And so this is actually reading all of these indices from the snapshot that we took and writing those collections of mappings and settings onto our source cluster. Okay, so migrated items now. Otherwise, this is the same data, but instead of migration candidates, now we actually have migrated items. And this is showing, again, 0 issues detected, which is what we hoped to see. So we can do another cat indices call now, and you can see that we have a lot of indices on our target cluster, pretty much the same list as on our source cluster, plus the system indices that were there already, but they don't have any docs. If something goes wrong or you wanted to look back and check what happened during your metadata migration, we store logs for every metadata migration. And the way to access them, is this shared logs output drive, which is an EFS volume attached to the ECS instance. And I'm auto-completing here to metadata, then the latest one here. These have all of our metadata evaluate logs, so putting in the date. And you can see here, this is the same output we got when we were running this. So it gives us a clear output of which indices were migrated if we had a question about that. And if there had been any errors along the way, this would be in there as well. We have migrated our metadata, so on our target cluster now we have a lot of indices with no data in them. And now we're actually going to start moving these documents. So we are going to use Reindex from Snapshot is our tool to do data backfill here. What's going to happen under the hood is when I do a console backfill start, it's going to increase the desired tasks for our Reindex from Snapshot service in ECS. And then each of those is going to look for the snapshot in the place we've specified, the bucket and repo we registered, and start interpreting the Lucene data in that snapshot and extracting the source of all the documents that we have in here. And then using bulk requests to write those requests to the target. So I'm just gonna start it. Oh, we had the default set to 5 instances. And this is, it's ECS, so it takes a minute to actually get going. But we can jump over here, and this is the actual migration ECS cluster and the reindex from Snapshot service, and we can get an overview of it. So you can see that there's 5 tasks desired. Those are presumably all starting up right now. Yeah, created 30 seconds ago. So this will take, all right, we've got some of them running. We can run console status with this deep check flag to get a deeper view of what's going on inside the cluster. You can see that the backfill status is running, which is what we would expect after starting it. And we have 5 instances running out of the desired 5. We have a total of 42 work items. This number usually corresponds pretty closely with the number of shards. If you remember from the snapshot stage, I believe we had 43 shards. So there's probably a system index that we're not migrating that explains that missing shard basically from our total here. As the migration progresses, work items start to not be exactly synonymous with shards, but in general, the backfill works on a shard by shard basis. So basically each worker here uses the migration's working state index that we can see added right here to find a shard or a work item that no one else is working on, picks it up, downloads the files from S3, and then reads the Lucene indices underlying that Elasticsearch or OpenSearch shard to extract the source documents and write them to the target cluster. Each worker or each process gets about 10 minutes at first to work on an item. And when those 10 minutes are done, it will basically checkpoint its progress by creating a new work item and marking its current one as complete. So as we go, the number of total work items will increase if there are large shards, potentially pretty dramatically, as kind of new partial shard work items are created. The 10-minute limit, if you are looking at your tasks here, and you can see as tasks are finishing that some of them are running for longer, some of them are running for shorter. That's also pretty normal behavior. Depending on the size of the shard, the workers kind of adjust their default runtime. So if a worker grabs a really large shard that takes, 8 minutes to just download it to the worker, and it's only been able to index documents for 2 minutes, it will effectively leave a note in that working state index so that the next worker to pick up that shard gets a 20-minute window to work with. So it has a chance to actually write more data than just, 2 minutes worth. We can also take a look here at the logs. So let's grab, this is a pretty random task. Which one of these that's working, and we'll view it in CloudWatch. Okay, so just to start from the top here and give you a rough idea of what you might see, this is just the RFS command, how it's getting started, which is potentially helpful for debugging, but usually shouldn't matter too much. Some more kind of configuration stuff. In this case, we don't have any transformations set up. Again, we'll get to those in a little bit. And then it starts downloading the file from S3. And this worker is actually must have been the very first one to get going because it realized that the shard work items had not been prepared. So this particular work item is checking how many shards are in each index and kind of configuring that shared source of truth for all the workers. At some point along here, yeah, this is basically when that process finished and a new process started up to actually start migrating some documents. So it claimed this particular shard. So this logs instance starting from document 0. It's downloading the file. That's the metadata file. So we get the shard size in bytes. And then it's downloading the full shard. We can zoom through that, the total number of documents. And then it starts putting together bulk requests. So basically we're putting, these must be pretty small documents because we're putting 55,000 of them in each bulk request. And you can see it basically making progress through that shard. And then it completed reindexing for that shard. So it shut down that process. And then it started up again with a new process, which claimed a different logs shard. And we can see the same process happening again, that it's downloading and unpacking the S3 files, writing bulk requests with, again, about 55,000 at a time, and it finished another shard. So this is, this is a very happy example of what logs look like. At this point, you can see reindexing was completed for this log shard 3, and this task started on another shard from the work coordination index. While this continues running, I think we started it about 10 minutes ago. We can go to CloudWatch, where we automatically deploy a dashboard for Reindex from Snapshot for each stage. So first of all, make sure the stage name matches here. And then second of all, select the target cluster domain name here so that we can match up the metrics from the target cluster with the RFS metrics. I'm just going to go to an hour here. And you can see these are starting with some of the target cluster metrics. This is when we started RFS, and we went from no documents ingesting on the target cluster to somewhere around 6,000 a minute. Our number of searchable documents is increasing rapidly. These are the status codes that we're seeing on that target cluster. So we're seeing mostly 2xx's, which is great. That's what we hope to see. We're seeing a couple 4xx's, which could be target cluster being overwhelmed or something like that. We can take a look in the logs in a minute to see if we can figure out what those are and if we're worried about them. And here, target cluster CPU utilization. In general, the goal during RFS is to more or less max out the cluster without it starting to throttle us. So you can control that in part by scaling the RFS workers in and out. So in this case, we can say we probably have a little extra space on this target cluster. Instead of having 5 workers, let's have 10. So we'll have to wait a minute to see that really show up, but quickly we now want 10. We have 6 that are pending and 4 that are still running. And within a couple minutes, getting data to CloudWatch is not instantaneous, as I'm sure you know. We'll see that reflected on this dashboard. We also have some stats RFS directly, the number of workers, for instance. So we had 5. It looks like they all finished their leases. Oh, sorry, this is just a drop of 1. Okay, so one of them finished and shut down there and then started back up again. Again, within a couple minutes, we'll see this jump up to 10. And in general, you know, the little dips of one finishing and then starting back up again are totally expected. So it should be mostly around the desired count, but a little bit below that is healthy and normal. And then these are stats for the RFS worker instances, for their CPU and memory utilization. Let's see here. Okay, so now we've got 10 running. So almost all of our work items have been claimed. We only have 4 left here. In general, that is the 2 limitations to scaling are that if you have too many workers actively writing documents, you can overload your target cluster and then it gets locked up and no one can write, and that slows the overall process down. And second, that if you run out of work items for those workers to grab, there will be a handful of them that are basically just cycling themselves on and off and looking for work items. They add a very small load to the target cluster, just checking that work items index, but they're not doing you any good anymore. They're not actually working on anything, and they will, if all the work items are claimed, they'll never find something to do. So either if you have a cluster that has very few shards in the first place, don't scale above that number of shards. And second of all, as you start to reach the end of your work, won't get much value out of having the workers scaled way up because there just isn't enough work to grab. All right, so we're slowly making progress there. And if we check here, yep, you can see our count of workers has jumped. Cat indices to verify that. And we should, if we were to compare all these numbers, we should see that they're starting to line up. So this logs 201998 and 201998 have the same number of documents. So that index, all of the shards are completed, all 5 shards. So along with console, backfill, start, and status, we have 2 other commands that may be helpful. We'll do backfill pause. And in this case, we're basically, what it does is it just sets the number of desired tasks to 0. You can see that backfill status, it created new work items now that everything has shut down. Kind of marked the progress on the old ones and then created new ones to indicate how far we were through those. When you do a backfill pause, you are welcome. Your next step could be scale 1, and everything will work perfectly. It'll start picking up one of those items and working on it once it actually gets started up. There's another command, which is console backfill stop. I'm not going to run it right now, but we will in a couple minutes. Stop saves the state of this migration's working state. Basically copies that index out and stores it in our logs, and then deletes it, as well as shutting all the workers down. And the advantage, or the reason you would do that, is that if you wanted to run a new backfill to start from scratch or to do a different index or something like that, or based on a different snapshot, having a migrations working state in the target cluster will mess that up because it would be basically inaccurate data for the new backfill process. However, the migrations working state is a very useful piece of debugging and kind of progress tracking data, so it is not helpful for it to be totally lost by just deleting the index without saving it first. My backfill has been running for a while now, probably long enough, and so I'm going to show you how to finish a migration. I'm going to start with backfill status, and you can see that the status shows that it's running with a couple instances in various states. This is commonly a common kind of catch point for customers, that they look at this and it looks like the migration is ongoing. However, if you add that deep check flag, you can see that actually all of my work items have been completed. So there's no more work to migrate. And this is a good time to have a customer, verify the data looks the way they expect with cat indices. Oops, that's clusters cat indices. And in general, you should expect to see the document counts match up exactly or pretty close to it. I changed some settings on this run so they won't match exactly, but they should be quite close. Migration is done and it's time to stop it. It does not scale down on its own, so it is a manual step to stop it and stop the workers here. And this is when we use the console backfill stop command that we mentioned earlier. This one will, okay, so it stops the migration. It sets it to 0 workers and waits for them to complete so that there's not kind of active things happening in the cluster. And then it archives the contents of the working state to this file in the logs directory. In this case, that should show a pretty successful run, but if the customer encountered issues along the way, that's one spot that might be helpful for diagnostic information. We can take a quick look at that here. Oops. Okay, here we go. And so you can see this is the structure of the documents inside this migrations working state. In general, if you're looking at this, the most useful piece is probably when each work item was completed. This is the name of each work item. So these are, the index, the shard number, and then the starting document count. So this is shard 2 of this index, shard 4 of that index. These are all starting at 0, so they're the initially created ones. And then later on, you see some that start at much higher document counts. These are kind of the successor items or the partial shard items that we were talking about earlier. You also, in some cases, this next acquisition lease exponent could be a helpful tool. This is basically if the shards are very large and it's taking a long time to download them. For each kind of new item, this number goes higher and higher to give the worker a longer amount of time to look at it. So if you're kind of debugging an issue, that also might be a piece to look at there. And now I'm just going to say, let's say we finished our migration. All our workers should be stopped now. We did a stop. Yep. The customer investigates their data and discovers that something doesn't look the way they expected. Maybe the mapping was not right, and so the ingested data is not right. So I'm going to do a quick demo of how you basically change the settings and start over. So we're going to start. There's a command here. So I'm also going to do a quick, for any of the console commands, you can use help to get some info related on, some info on what is available. So the most useful options here are you can add a verbose flag after console to get, more output. And then these are all the commands available. So in this case, we're running a clusters command, and we'll do another help at that level, and you can see the available cluster commands. In this case, we're going to do clear indices, and let's do another help just to show you that this one required argument is specifying the cluster. So I'm going to do cluster target. Obviously, this is one to use with caution because it is deleting all our indices on a given cluster. It does check with you first, and in this case, yes, target, we're going to do that. Cat indices, we can see that's now an empty cluster. If the mappings were the only issue, then at this point the user might just be able to change their mappings, run a metadata migrate, and then migrate their data again. But I'm going to show slightly more involved case. I'm going to exit out of the migration console, so now I'm on the Bootstrap box. Just to show you where we are. This is where your cdk.context file is. So this is the context settings for this one. And the piece I'm going to look at right now is this reindex from snapshot extra args. So let me pull up the documentation. If you're on the main documentation configuration options page for Backfill, there's this reindex from snapshot extra args. And so we can go to this, and most of these a user should never have to touch. They're kind of handled internally, and it should be pretty transparent. In some cases, if the user has weirdly shaped data or something like that, it might be something they need to modify. So in this case, let's say document size per bulk request, they've figured out that for their documents, it just works a lot better with much smaller bulk requests. So the default is 10 megabytes. We're gonna change that to, let's say, 1 megabyte or so. So we're gonna come back to our context file here and do reindex from snapshot extra args. Make sure I got that right. Reindex from snapshot extra args. And then we'll specify document size per bulk request, about 1,000,000 bytes. So there we go. And then I'll save this file and then run cdk deploy again. And that will redeploy all of our infrastructure, but in particular, in this case, it will modify the task definition for the ECS worker tasks for reindex from snapshot with this new parameter, which is what I need in this case. So this is great, doing its thing, and we'll finish shortly. And at that point, you can log back into the migration console and start a new migration with that new setting applied. I'm going to return for a few minutes to this question of debugging the 4x errors that we saw previously. So again, I'm back on the reindex from snapshot dashboard that's automatically deployed. You can see that this is the window where RFS was running and adding documents to the target cluster. And here again are our status codes. So majority 2xx's, but we have this little spike of 4xx's as well. So that's what I'm going to be looking at. In this case, I actually have some of the capture and replay infrastructure deployed. So there's kind of a baseline level of 4x errors that are just status code checks that we're not concerned about. But this spike goes above that background level. So we're going to take a look and see if we can figure out what's going on there. I'm going to start by searching the logs. This is the reindex from snapshot logs in CloudWatch. And I'm going to search all of them. And you can kind of use these however you prefer to dig through logs. But my starting step here is going to be looking for something where we say that the status starts with a 4. And so here we go. We've got a bunch of 400 bad requests. So this seems like it likely corresponds with our spike here, but we'll verify that in a minute. And I'm going to click into one of these log streams to get a better look at what's happening. Okay, so you can see here that this is the worker is running, has pulled a work item, downloads the shards, and is writing documents, and then that process shuts down. So that was a totally successful run, and then it starts up again, another process on this worker. And this time we run into an error, an exception parsing this response. Here's our 400. That's what we found in our search. And then here's the full payload. So what you can see here is that this is a call against our migrations working state index, our work coordination system. And the error here is that the times indicated between the client and the server are too different, so it can't proceed. This is an artifact or result of our distributed system. We have many workers that are talking to this coordinating system, and in order for these leases, these kind of 10-minute windows to work on a particular shard, to work and to be coordinated across these workers, they need to make sure that they have the same clock time as the server. And so they do a check for that basically when they try to request a lease. And if the clock times are too different, it says basically this is invalid, we can't continue, and throws an error. So that is the error we get here. And when the worker receives this error, it shuts down and a new worker starts up, hopefully with a more aligned clock time with the target cluster. So in this case, this is the system behaving well. Obviously having the clocks misaligned isn't ideal, but that's going to happen in a distributed system. And the most important thing here is that the workers caught that and are dealing with it correctly, which is to not continue. So let me do a quick check to make sure that this is what explains these results. I'm going to just grab this reason string because that's pretty unambiguous. I'm going to take all of these logs, do view logs, insights, filter, add that filter, and then let me make sure that my window matches up with when I was running this and what we were looking at in the dashboard. Take that limit off. And then we can see that these spikes here appear to more or less correlate with these spikes here with what we're seeing on the target cluster. In this case, the other validation that we have that things worked out well in the end is that our document counts matched. So that kind of reinforces what we're seeing in this data, which is that these errors were workers talking to the coordinating index, not workers attempting to write documents and failing. That does bring up the question, however, of what to do if the errors that you're seeing are impacting document delivery. One of the potential reasons for this is that the documents that you're trying to write are malformed for the target cluster. They don't line up with the new mapping, for instance, or they contain field type that is incompatible with the new version. RFS automatically retries requests a number of times. So if it's a transient error, hopefully that will get past that. One of the potential reasons messages can't be delivered is because the target cluster is overloaded and blocking writes. So that's something to check on the health of the target cluster separately. But if there are specific requests that are failing to be written, we basically have a dead letter queue, a list of failed requests that gets written to the shared logs output on the migration console. These are sorted by, or kind of, shared log as output. We have this reindex from Snapshot default, and then we get a list of all the host names that may have encountered a failed request. So there are a lot of those. I'm going to quickly just grab one of them so I can show you what's in there, and then how to take a look across all of them. And then failed request.log. So this is the file that would have any failed requests. In this case, I'm going to take this ls command and substitute a wildcard for that particular host, and then make it wc, a word count, and run that. And that will check across all of the hosts. Do any of them have content in this failed requests log? And in this case, these nice columns of zeros, and then this zero total at the bottom confirms that these are all empty files. We did not have any persistently failed documents on this run, which is what we expected considering that all the documents made it and that the counts matched up. If you did have any failures here, you would see them in the total, and then you could figure out which file they came from and go investigate that file in particular and figure out why that request had been failing.